Got the homework. A couple things I'm going to have to point out. Again, we're not going to have time to talk about all the homework questions. There are some of these that we're going to be building on, so I'll make sure we address them. Number five. Okay. So one thing about proofs, and this is sometimes the frustrating thing about geometry for students, is that, are you really expecting me to remember everything we've talked about this year? Yes. Okay. So back when we said, let C be the midpoint of AB. If you're told C is a midpoint, if you have a midpoint, what do midpoints create? Two congruent segments, sides, whatever you want to call them in the picture, right? Two congruent segments. So in that proof hacks page, the proof tips page, if you have that out, if you want to bookmark it, if you still have that in your notebook, the proof tips, if you're given a midpoint, you're going to have two congruent sides, which gives us a pair of S's in SAS, doesn't it? S's. So as soon as you see C's the midpoint, here's what I do. Now, we have to be careful. I was going to say something that I need to correct myself. There are some times that C is only the midpoint of one segment. There are some times that C is the midpoint of two segments. Well, what if the C is the midpoint of ZK? I don't know. Then these two are congruent. So if you're told C is the midpoint of two segments, you have two pairs of congruent segments now. And that was the case here. So he's the midpoint of AE. AE. And then BD. So those segments are congruent to each other, but do you agree the blue and red segments aren't necessarily congruent? Let me say it again. These segments are congruent to each other, but doesn't necessarily mean the red and blue segments are congruent. Got that? Awesome. All right, that gives us a pair of S's, another pair of S's. And I probably would have put this stuff up here because I was told there's a midpoint. That's probably the next thing I would say. So if you had that as step 2, I'm with you on that one. All right. Then we got an hourglass shape. You guys all know what an hourglass is? Yeah. The thing the sand goes through. Yeah, hourglass. Anytime you have triangles point to point, like an hourglass, you're going to have vertical angles congruent. Look for it. Look for the vertical angles there. Vertical angles theorem. Did you name them in the correct order? ACB, this angle ACB. If you said A first, you had to say E first over here, ECD, because A and E are the corresponding angles. Now, could you have had BCA and DCE? Yes, that's fine too. Are you with me? At that point, we have SAS. The triangles are congruent by SAS. That's not that bad, is it? Not that bad. So things to look for. Are you ready? Vertical angles. Definition of midpoint. We learned one yesterday. It was when you're told lines are parallel, look for. When there's lines parallel, transversal, look for. Alternate interior. The other three we can forget about for a little bit. Oh, I shouldn't have said that. Now you gotta forget about it. All right. What else? Overlapping side. Triangles share a side. We're going to use the reflexive property. Those are all things that are keep repeating. Look for them. All right. In triangles like this, what the first thing I do is how many triangles do you see there? I see more than that. I see 1, 2, 3, 4, 5. It's like one of those pictures. 6, 7, 8. You know the pictures I'm talking about? Look, you keep seeing more and more. Anyway, the first thing I do is I outline the triangles they want me to prove congruent so I know where I'm working. So PQT, and RST. Oh, okay. So now I can see those are point to point. We're going to use the vertical angles theorem. Okay. I'm told 1 pair, 2 pairs. Oh, this is easy. I'm given two pairs of sides. Use the vertical angles theorem. SAS, done. Emma.
When we're writing out the reasons, do we have to put the congruence theorem, or can we just put like SAS and vertical angles?
Great question. Just put SAS and vertical angles. Yep. They're being pretty nerdy about it. All right. 19, they went through the congruence end of it because, help me out, in your picture, were these tick marks marked?
Yeah.
Okay, so you probably set things equal because of that. I'm about to ask a question kind of randomly. Is C the midpoint of AE? No. Or we don't know. Okay, we don't know. This is marked with one tick mark, so is that one. This one's marked with two tick marks. Now, when you solve for x and y and plug them back in, is there a possibility that these four sides are all the same? There's a possibility, okay? So it could be the midpoint, but it's not showing us it's the midpoint. So be careful which ones you set equal. Questions? Any questions on the homework? Emma?
19, the actual like algebra part, will something like that be on our test?
That system of equations?
Yeah.
Probably not on this quiz. We need to get into it more because that will keep coming up. Okay. All right. So again, do you have your 5-3 guided notes out from yesterday? Do you have them out? Because we still needed to wrap that up. Whoa. Reaction time.
Yeah. You notice that we haven't done 5.3 yet, right?
5-3. We're gonna wrap up. 5-4. All right, we're gonna go through this quickly. All right, I think we did this one in class. This class got to that one. All right, let's talk about this one. What can you conclude about PTS? PTS and RQT. Well, I would outline them. I would look at it. Makes me proud. Who can raise their hand and tell me what they notice about these triangles? What else can we tell? Infer. Who could raise their hand and tell me? Miss Page. Got some vertical angles. So let's say angle STP is congruent to angle. Now you're probably thinking, Mr. Westphal, it didn't really say to like, it said just what can you conclude? And it's easy to just say now, oh, they're congruent by SAS, right? But you have to tell the information that leads you to that answer, right? Mackenzie, do you want to take a stab at the order for the? So I said STP in the top triangle. What order would you say in the bottom one for this angle? QTR, thank you. QTR by the vertical angles theorem. Vertical angles theorem. So triangle PTS is congruent to triangle RTQ by, what do you think, Chase?
The side angle side.
Side angle side. And it's kind of boring right now because that's the only one we know. It's the only trick we know right now. Side, angle, where they meet, other side, come together at that angle that you're told is congruent. Awesome. Next, another proof. Okay. B is the midpoint. Should be jumping off the page at you. Midpoint. If I have a midpoint, I'm going to have two congruent sides. B is the midpoint of AD. So right away, I trace AD. I put B in the middle, and I put tick mark, tick mark. But I have to remind myself I better write that down in the proof as well. Next given. And again, A good habit is just to read through the problem and make a plan. Don't just start writing stuff down. Make a plan. A, B, C, and D, B, C are right angles. A, B, C, and D, B, C are right angles. Did they tell us they're congruent? No. So we need to make a connection between saying they're right angles to saying they're congruent, because it doesn't count as a or an S until you've said that they're congruent. All right, let's start. And just to finish off our plan, we see two triangles like this. And I didn't say this yesterday. I didn't get to it in this class, but I use my hands as the two triangles. Okay, watch up here. I have two triangles like this. Did we see some triangles yesterday like this? Remember how the order changed? AC was congruent to CA?
Yeah.
Okay. Now, I don't think it's that complicated, but if they're like this, it will be AC congruent to AC. They're in the same order because they're just a reflection of one another. If they're like this, it's going to be AC and then CA. So, pinky to pinky, pinky to palm. All right, reversed. Reverse. All right. So we're going to see the what property? Reflexive. Very good. Reflexive. Therefore, the triangles are congruent by. The triangles are congruent. Triangles are congruent by SAS. SAS. All right. Step 1. B is the midpoint of AD. Given. I'm gonna give that its own line because it's a separate thought from the other one. Caden, what's the result? What's step 2?
Angle ABC.
Oh, hold on 1 second. If we say it's the midpoint, if we say B is the midpoint, we need to say what two sides?
AB is congruent to BD.
Is it ABBD or is it ABDB?
DB.
Yeah. ABDB. You can use the order up there. DB. Once again, this is kind of helping you guys as we go. If you forget the order, use the congruent statement up here. If I say AB, then I have to say DB. Okay, what's the reason?
Definition of midpoint.
Perfect. One pair of S's down. Step 3. Angle ABC and angle DBC are right. Given. Ooh, we got to dig deep here. If you have your bookmark to that proof tips, it's way back then. Why can we say angle ABC is now congruent to angle DBC? Who remembers? Who remembers? Jared, you got this?
Wasn't it the right angle congruent?
Nice. The right angle congruence theorem. It was a life-changing theorem. Guess what it said? All right angles are congruent. Life-changing. It's kind of a stupid one, isn't it? But do you see how you have to go from saying they're right to saying they're congruent? Because congruence is what counts as the A in SAS. Make sense? Well, we're out of givens. We're out of givens. Anthony, what do you think? What's the other S in this problem? What haven't we used yet?
The reflexive.
Yeah. Give me the segments that are congruent.
CD and CD again.
Yeah. How'd you know they're not changed order.
Because it does the shit out of the picture.
Yeah, it's obvious from the picture, 1. And 2, I could also say CB. Oh, CB. It's the same order in these triangles. The reflexive property. Lot of repetition in proofs. Lot of repetition. That was our last pair of S's we needed. How many of you are going to be circling S or A or S as you go? How many of you like that? Okay. Does it need to be in that order? SAS? Could it be a SSA in over here, but still be SAS? Yeah, because it's where the A is in the picture that makes it SAS, right? Triangle. A, B, C. Congruent to triangle. D, B, C. And we just have our one little trick. S, A, S. Not bad. Not bad. Is this on your papers?
Yeah.
All right. Let's talk about it. Is there enough information to prove that these triangles are congruent? Don't blurt out. Just take a look at it. Think about it. Who votes no? Who votes yes? Yeah, because X, Z, and triangle 1 is congruent to ZX. Good. X, Z, congruent to ZX in triangle 2, right? They're reversed. So you have to reverse the order of those. So therefore, the triangles are congruent by... Nope, we don't prove triangles congruent by reflexive. The triangles are congruent by SAS, right? All right, could I show you something to be careful of that I have students do, which I know you'll never do? What's wrong about this? You have to watch for me to, you have to see it. I can't really say it in words. What if a student says, I guess we're not ready for that. You haven't learned ASA yet. So never mind. I was going to say something, but we're not ready for it. We'll save that for later. Ooh, cliffhanger. There will be an angle side angle. Yep. That concludes your 5-3 notes. Did I get up through all the problems on it?
Yeah.
Awesome. 5-4 notes.
Yay.
Equilateral and isosceles triangles. Just kind of. Need one? If you're thinking about future planning, having family, kids and stuff. Isosceles would be a great name for a child. Yeah, because they're guaranteed to have the 2 congruent lines, right?
No, that or
All right, your first fill-in.
oh, that's true.
In an isosceles triangle, it's always good to have 2 congruent lines, isn't it? That we don't hobble.
Sure, I'm actually second here.
That's why you're not first.
And you have base angles that are congruent. There's some fill-ins on this page. Are you guys filling it in? Chase, you filling it in? Take good notes.
Okay, you found it?
Yeah, I did.
You did?
Yeah.
Yes, babe.
Are we supposed to write all of that down for this and those things?
I don't think you need all of it. Just honestly, I think the picture, if you fill in the picture, you can see all the arrows are pointed to that stuff. I think if you guys fill that in, you'll be good. It's not that complex. All right, question for you. In my picture, ABC over there, what are the legs? What two sides are the legs? AC and BC. What are the base angles? Yeah, you see base does not mean bottom. Base does not mean bottom. Because if I rotate that triangle, the base angles are on the top, right? Base angles are, how can we describe that to a student that's just learning this? Because you guys know about isosceles triangles, right? How could you explain the base angles? Because they're always going to be congruent, by the way. The base angles of an isosceles triangle are always going to be congruent. How could we explain where they are on the triangle, Tally?
Facing out the same direction.
I like that. Yeah. They're facing the congruent sides or facing in the same direction as each other. What do you mean?
Because I explained it bad. Because the vertex angle goes down and then they go out, like reflecting.
But what about like if I turn it?
Then they're going down and then the one. I don't know.
No, you're on the track. Christian?
Where the legs and base meet.
Where the legs and base meet. Yeah. Because if I were to say, hey, look at where the legs meet, you'd be up here, right? That's the vertex angle. The other two are the base angles. Not that challenging. We don't need to write all this down, but there's the base angles theorem and the converse. Okay? Do you remember what the converse was? What does the converse of a theorem do? Switches the... Huh?
Switches the if.
The if, good. It switches the hypothesis and the conclusion. Switches the if and the then. Okay? So the base angles theorem says if two sides of a triangle are congruent, the angles opposite them are congruent. Tally, that's what you were getting after. That opposite from those legs, right? The converse says if two angles of a triangle are congruent, the sides opposite them are congruent. So one says two sides are congruent, therefore the angles are. The other one says if the angles are, then the sides are. So it's all about what you're given. Are you given two angles are congruent? Or are you given two sides are congruent? Some might say it's really all about that base. Listen, you teach geometry for 17 years, you have to entertain yourself after a while. I've been teaching, oh my gosh, I just had a moment. I've taught geometry longer than you guys have been alive, haven't I? Oh my gosh. Where, like...
Great observation.
I'm having an existential crisis right now. Give me a few minutes. All right. Are you ready? This book does a terrible job of explaining the next idea. All right. And then they give you a proof and they expect you to have magically learned this idea. So I need to teach you the idea. And I put a special page in there and you might have to write it somewhere in the blank area because as I was prepping for the lesson, I'm like, wow, they didn't even explain that at all. So I added a slide and it's called CPCTC. Wow, that was quite the reaction. I'll take that as excitement. All right. CPCTC. Corresponding parts of congruent triangles are congruent. CPCTC. Cool people, come to class. Right, Olivia?
Huh?
Cool people, come to class.
I can.
Consistently.
I've been here all week.
Oh, it's not. Whoa.
It's Tuesday.
Yeah.
Ooh, let's have a Olivia streak.
It's Tuesday.
Monday. Tuesday.
Wednesday's not gonna be here.
Thursday. Friday. You were here Monday, right?
Yes.
All right. You were here today, mostly.
2 days. 2 days.
Yeah, 2 days straight. Who cares about Snapchat? Let's keep this streak going. Corresponding parts of congruent triangles are congruent.
We just send pictures and check
Corresponding parts of congruent triangles are congruent. How much explanation do you need? Does that make sense, or do you need to explain it? Corresponding parts of what kind of triangles? Congruent triangles. So we're only talking about congruent triangles here. Corresponding parts of congruent triangles are congruent. Are you ready? Are these two triangles congruent?
Yes.
What does that mean? All their angles
Are the same.
and all their sides.
Are the same.
But are they all marked? But are they?
Yes.
Why?
Because of C.
Good. So, ready? These triangles are identical by SAS. They're identical by SAS. But Mr. Westphal, you didn't mark that angle D and angle B are congruent. Are they? Yeah, because aren't D and B the corresponding parts? Like they're the angles that go together in these congruent triangles?
Yeah.
Right? Mr. Westphal, what about these sides? Well, I didn't say it when I imagine we just did a proof on this and everything in blue was marked congruent during the proof. SAS. Are these two sides congruent?
Yeah.
Yes, but they weren't marked. Yeah, but once you've gotten to SAS, you've proved the triangles are identical. Everything else that isn't marked has to be congruent because corresponding parts of these SAS congruent triangles have to be congruent. Does that make sense? Awesome. Then they ask us to kind of use it. So look at the given and look at the proof. What do you notice is different about this problem?
And once it's tells them the angle is congruent.
Yeah.
The whole time.
They're asking us to prove angles are congruent, not the triangles. I have good news for you. Good news. This proof is a triangle congruence proof plus one step. And our only triangle congruence trick right now is SAS. So here's what you're going to do. You're going to get to SAS, and then, oh, look, the triangles are congruent. Angle B has to be congruent to angle C by CP, CTC. Cool people. Cool people come to class.
Do we write that?
Do we write what?
Like I did on the board for the quiz. Like CP.
I beg your pardon?
CP, CTC.
Yeah. Is that a reason we can write that?
Yes.
Okay.
Yeah. Corresponding parts of congruent triangles are congruent. Are you ready? Here we go. We're going to go quickly. A, B. Shh. Congruent to AC. Given. A, B. AC. Tick, tick. Now, I'm going to also put angle B. Actually, you know what? No, I'm going to make up my own given because in the book they changed the problem a bit and I didn't love it. Are you ready? A, D bisects angle BAC. Ooh, got to dig deep. Back to the proof tips, way back when. If I'm told I have an angle bisector, what is an angle bisector? It cuts an angle in half and creates two congruent angles. Do not say sides. If I cut a cake in half with a sword, I get two congruent swords, don't I? No! I get two congruent pieces of cake because the sword is the bisector. The cake has been bisected. AD bisects angle BAC. AD is the sword. BAC is the cake. If you're cutting an angle in half, you get two congruent angles. If you cut a notebook in half, is this important?
No.
Okay.
Well, actually,
Is it the math one?
yeah.
I won't do that one. Just kidding. You get two congruent
No.
notebooks. You cut a segment in half, you get two congruent segments. All right. I think you get my point. Sorry, Josh. Didn't mean to bisect your math. If it was English, I would have had no issues. So you have to say it first, then you have to say the result next. Anytime you're told there's a bisector, it's a two steps to get there. One to say it's been a bisector, the second one to say the result. I'll put them in the same color. Angle blah 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 is congruent to angle blah blah blah. What two angles are congruent because of the bisector? McKenna? That one's a bad one, yeah. Bad. Angle BAD. And you said perfect order. Bad and CAD. Definition of a... Yeah, I'm even going to say angle bisector. If you just put bisector, I'd give you credit. I want to be very specific because a mistake students make is they will say two segments are congruent. Do you agree that angle bisector has nothing to do with any of the segments up here? If I have this angle and I cut it in half, I have two congruent angles. Do you agree that has nothing to do with these two sides? Zero to do with those two sides. Yes?
Yeah.
All right, we have a pair of sides from step one. We have a pair of angles from step two. And now we have to do something on our own. Look, guess what we see? We see triangles sharing a side. Quentin, what do you think? Quentin, what do you think?
80 is congruent to 80.
Perfect. Same order. Pinky to pinky. Reason?
Reflecting.
Reflexive. Yep, with an X. Reflexive property. If it was reflective, when they might need some sunglasses. Just reflexive. So we got boom. Oh, look. Triangle. Now here's the deal. They didn't give you an order to steal. So we have to name these triangles in the correct order. But you know what? McKenna gave us a nice order up here in step 3. Now we're not talking about angles anymore. Now we're talking about the whole triangles. But we can still use that order, can't we? Does that make sense? Yes or no? The order that she named them in, we checked up there. It was good. So the triangle can be named in that order. And the reason those triangles are congruent is SAS. Little sass. Olivia, this lesson's all about you. All right. Step 6. Boom roasted. All right. Can we say those angles are congruent? Is B congruent to C? I don't, do I know? Yes, because the triangles are congruent. Everything else that we didn't name has to be congruent. Angle B, congruent to angle, was it C?
Yeah.
By? CPCTC. Mr. Westfall, are you going to count it off if I don't spell CPCTC correctly?
Yeah.
Absolutely, with a smile on my face. CPCTC. Let's say it together. CPCTC. CPCTC. Elizabeth, I don't want to leave you out. Ready? CPCTC. Corresponding parts of congruent triangles are congruent. By the way, the Ohio State test at the end of the year will have CPCTC on it. It will abbreviate it as CPCTC. All right, it won't write it all out. All right. Do you remember what a corollary is?
No.
A corollary is it's like a special case of a theorem. Special case of a theorem. This is an equilateral triangle. Do you agree if it has 3 congruent sides, it has to have 3 congruent angles? Is that obvious to you or not?
Yeah.
If it's equilateral, it has to be equiangular. If it's equilateral, it has to be equiangular. And the converse of that's also true. If it's equiangular, it has to be equilateral. All right, now you're going to see some of these on your homework tonight. So I want to show you guys what to look for. How many degrees are in a triangle?
180.
180. What if they're all the same? Quentin's all over this. All of them are 60. Have to be. Every single time. 60 degrees, 60 degrees, 60 degrees. If it's equilateral and equiangular. 60, 60, 60. So on a problem, what if they say, solve for x, and they put like a 6x up here. You set 6x equal to 60 and solve for x, right? Make sense? All right, I'll come back to this in just 1 second. I just want to make sure you get to this problem. Classify this triangle right now. Scalene, equilateral, isosceles, equilateral. Okay, but wait a minute. It said find the measure of the angles. Oh, if it's equilateral, it's also equiangular, so they're all 60. All right, what about one like this? Watch up here. This one is equiangular. I can see it's equiangular, angle. So it must be equilateral. So y must equal 4. And this side must be 4. And this one down here is, well, wait a minute. Nope. This triangle is classified as isosceles because the base angles are congruent. If the base angles are congruent, then these sides that Tally told us they're pointing to are congruent. So x plus 1 equals 4. So x equals 3. X equals 3. Y equals 4. Do you see how you have to kind of work around that picture? Like a little puzzle. Like a puzzle. All right, you get a couple of those on the homework. Speaking of homework. Yeah, that was a short homework last night.
I mean, I would be willing to go for another 4 problems. And only 4.
So I took a couple problems from 5.3 to finish up and a couple from 5.4. It's up on the board for your viewing enjoyment. All right, quick little reminder. Tomorrow is going to be a worksheet day. I'll go over homework. We'll go over a worksheet. Hey guys, listen. I have a meeting all day Thursday. I'll be here, but not here. All right? You're going to be getting a review video for a quiz on Friday. All right? I will post a quiz review. We'll work on it in class. The video will be posted of me going over it. The quiz will be Friday. All right? We've just finished going over the last bit of new content that will be on the quiz. Day 2, so yesterday.
Oh, I know. Oh, right now it's like it's going like that, and then now it's like it's like all that for 5 seconds. They stick it out.
Oh, sorry, same page as yesterday. I'll
You got him busy.
Do you want to check it now or?